Hello students. So today we will be studying about this chapter of matter and its composition. So how do we define matter? If you go and recollect the things that you have studied in your lower classes, probably in classes 5 or 6, you must have come across this word matter. And whenever you studied or you came across this word matter, most of the times it was defined in this manner that matter is something that has mass and that occupies space. So this is how matter is defined. It has some mass and yes, it occupies space. So everything around us in our daily life is one or the other form of matter. So the fact that I am speaking to you right now sitting at a table, that table is also a form of matter. In this case it's solid. The water that we drink every day, which is so much essential for our survival, that's another form of matter. In that case it's liquid. And if we look into the primary thing that keeps us alive, it is the oxygen from the air that we breathe. That's also a form of matter, however it's gaseous. However, apart from matter, there is something else as well, which is encompassing our everyday life, and that is energy. Yes, energy is also present, and energy, it does not occupy space. Say for example the electrical energy which is necessary in order to charge up my cell phone or this laptop where I am writing, that energy doesn't really occupy space. Similarly, the fact that you can hear me speak is because of the sound energy which is being generated by my vocal cords, but that sound energy doesn't really occupy space. So yes, there are other things around us as well apart from matter, but what is matter? Matter is something that must have mass, and yes, it will occupy space. And what is mass? The amount of matter which is contained in a body, that is called mass. The amount of matter contained in a body is called its mass. So more is the amount of matter in a body, we will say more massive it is. So you may take say two containers here, say one is container 1, the other one is container 2, and in container 1 this is the amount of water you have, and in container 2 this is the amount of water you have. It's almost filled to the brim. So which one of these two will have greater mass? Obviously the one which is filled to the brim, because that has got a greater amount of matter, in this case water, inside it. And yes, mass does occupy space as well. Mass occupies space. All materials occupy space, and anything that has mass will occupy space. That's same as saying that matter occupies space, because what is mass? It's the amount of matter contained in a body. So from here we can therefore say that the amount of space which is occupied by matter, the amount of space occupied by matter is called its volume. And we can do a very simple, a very brief experiment which will demonstrate this fact that yes, matter does occupy space. So we can take a glass tumbler like this, and within that tumbler we can place a glass. Now suppose this glass contains water up to this level. So this is the amount of water which is initially present in the glass. Now what we do is we take a stone. We take a stone which I am representing here in red, and we tie it with a thread and we suspend it into the water. Now initially the water which is present in this glass, it is filled up to the brim. This is the initial level of the water, that is before we have inserted the stone into it. So it is already filled to the brim. So now if we insert a stone into that glass, what will happen? The volume which is occupied by the stone, that much volume of water will be displaced from the glass, so it will overflow and it will collect here in the tumbler. So there will be a certain volume of water which will collect here in the tumbler. But this volume of water, that will be equal to the volume of the stone which we have inserted. So now if we take out the stone, so this is our glass and it has water up to this level because some amount of the water has flown out into the tumbler. So if we pour that remaining amount of water from the tumbler back into the glass, we find that it again gets filled to the brim. So this experiment, though simple, proves that yes, matter does occupy space, because had matter not occupied space, then the moment we would have inserted this stone into this glass filled with water, the excess water wouldn't have overflown. The excess water overflew because both the stone and this water here, both of them occupy space, and therefore both cannot occupy the same space. So the place where there was water initially, since it is now occupied by the stone, therefore the water overflew. So yes, matter has mass and it occupies space. Now what is matter composed of? So matter is something which we are talking of on a large scale. But if we look up into the matter at a very microscopic scale, what is it composed of? So say for example, I have a rod of iron here. But if I think that, well, I want to look into this small portion of this iron rod, I want to magnify and look into it, then what will I see into that magnified part? We may see this tiny spherical ball-like objects. And what are these things? These are the building blocks of matter. These are the building blocks of matter. What are they? They are molecules. But yes, the molecule, it isn't the most or the simplest form of matter, because molecules can further be made up of atoms. So atoms are something which we can say, yes, they are the fundamental building blocks. Obviously, when we will be studying about atoms and atomic structure in our higher classes, we will come to know that well, atoms themselves are again made up of more subatomic particles, whether it is the proton or the electron and so on. But as of now, we can treat that yes, atoms are the building blocks, because there is one thing about atoms, which is they are the smallest part of the matter. But atoms may or may not exist independently. So that is one of the reasons why we have molecules. Molecules are basically combinations of atoms, and molecules have this advantage, which is they can exist independently. Atoms combine to form molecules. So if we look at some examples, say for example the O2 molecule, the oxygen molecule, it is basically made up of two oxygen atoms. So there are two oxygen atoms. Similarly, if we look into the example of, say, the carbon dioxide molecule, the CO2 molecule, so it is made up of one carbon and two oxygen atoms. If we look into the ammonia, the NH3 molecule, it's made up of one nitrogen and three hydrogen atoms. So these atoms, they combine to give us molecules which have independent existence, and these molecules, they further add up to give us the matter on the large scale. If atoms of the same kind combine to give us a molecule, like in this case, in case of oxygen, atoms of same kind, both the atoms are of oxygen, they combine to give us the oxygen molecule. These are the cases when we say that this is atoms combining to form molecules of an element. And if the atoms of different kinds, like in this example or this example, here we have atoms of two kinds, here also we have atoms of two kinds, one of carbon, one of oxygen. When atoms of different kinds combine to give a molecule, we say they are forming the molecule of a compound. So I hope up to this it's clear to you. This entire idea of like that matter is made up of atoms or molecules, this is not the thought process of one single scientist. Philosophers and researchers from various countries, whether it is India, whether it is the ancient Greeks, all of them had different philosophies, different ideas about this. But the person who actually brought it into the scientific language by performing experiments on this for the first time, that was John Dalton. So after John Dalton gave his basic atomic theory, which he had proposed in the 19th century, that's in 1803, after that this entire study of atoms and molecules and what is actually happening at the subatomic level gained momentum. But yes, there were these ancient Indians like Kannada, or even the ancient Greeks like Democritus. They all also tried to think, they tried to question that what's happening deep down inside the matter. What is the building blocks? Okay, so now we will look how the atoms are arranged in the various different states of matter which we talked about, like the solids, the liquids and the gases. So first of all, when we have say more than one molecule, say these are the various molecules. Remember, molecules themselves can also be made up of atoms again. So when we have this different kind of molecules, they are held together. They have forces between themselves. And they are held together by what? They are held together by certain forces. And what are these forces called? Intermolecular forces of attraction. So these are intermolecular forces of attraction. They hold the molecules together. And greater the strength of this intermolecular force, lower will be this space, the distance between the molecules. This space is known as the intermolecular space. So if the intermolecular force of attraction is very high, the intermolecular space will be low, and vice versa. And that is how we can basically classify the three states of matter: the solids, the liquids and the gases. One finds that in solids, the molecules, they are very tightly, they are very closely packed to each other. This is what happens in solids. That is because in the solids, the intermolecular force of attraction, IF for short, that is very high. So the intermolecular space, let us call it IS, that intermolecular space is negligible, or one can say it's practically absent. The molecules are so closely packed. It is for this reason that the molecules in solids, they almost do not move. So we can say they hardly move. All they do is they vibrate about their mean positions. So if these are the molecules, they just vibrate about their mean positions. They hardly move. What happens in the gases is an extremely different case. In gases, the molecules are really far apart. So here the IF, that is to say the intermolecular force, it is negligible. The intermolecular force is negligible. And what about the intermolecular space? It's very large. The molecules are pretty far apart from each other. It's very large. The intermolecular force of attraction is the weakest in gases, whereas it is the strongest in solids. And it is for this reason that gases, they can move easily from one place to one another. That's why we can say that gases are fluids. They can easily move from one space to another. If we put some gas into a container, the gas will occupy the entire volume of the container. Whereas if I take say an empty container and put a solid ball into it, the ball will only occupy its own space, but not the entire space. And if we now look into the liquids, it's intermediate between the solids and gases. In liquids, the forces of attraction, that is the IF, that is lower than solids, because in solids the force is the strongest, but yes, it is higher, that is stronger than gases. And similarly, therefore, intermolecular space will be just the opposite. It will be higher than solids, the intermolecular space, but lower than gases. But whatever be the case, liquids can also flow. That's why we say that liquids are also fluids. Yes, liquids have a definite volume. Remember, gases don't. Gases don't have definite volume. They don't have a fixed volume. But yes, liquids have a definite volume. But what liquids don't have is no definite shape. So whatever be the shape of the container in which we keep the liquid will take the shape of that container, because it has no shape of its own. So basically, the properties of the solids, liquids and gases, as you can see now, is controlled, is governed by what is the intermolecular forces of attraction between the molecules, and what is the intermolecular space between them. So the force is the greatest or the strongest in solids and weakest in gases, and in liquids it is intermediate between solids and gases. And similarly, when it comes to intermolecular space, that intermolecular space is the largest in gases but least in solids, and in liquids they are intermediate. Solids cannot flow, they cannot move from one place to another, but yes, they do vibrate about their mean position. Whereas liquids and gases, they both can easily move. However, liquids have a definite volumes which gases don't. So gases have got the maximum fluidity. Gases have the maximum fluidity. So that ends our discussion on these different states of matter as to what makes up matter at the fundamental scale, and what is matter. It's something that occupies mass and space. So we shall end our discussion here. Thank you for your attention.